Hi, I want to take an opportunity to have one more look at a test of the difference between population means. And for this, we're going to take a look at a file that I have that's related to state tax versus household income. Now, residents in some states in the United States pay a state income tax in addition to federal tax. And many companies actually pay higher salaries in those states in order to attract employees because those employees will know that they'll have to pay tax out of their salary. So, what we want to do is take a look at household income in states that have no income tax compared to states that do have income tax. And the claim that we want to test here is that average household income is lower in states that have no income tax compared to states that do have income tax. And in order to review this, we're going to take a look at the data file that looks at household incomes in certain metropolitan areas within the United States. Okay, so this data file has a series of metropolitan areas across the United States. There's some 325 different different metropolitan areas. And then for each one, we have the average household income. And then lastly, we have whether or not that state charges state income tax or requires residents to pay state income tax. So let's take a look at this data and figure out whether or not we see a difference. Remember, the claim is that states that have no state income tax on average will have lower salaries, lower corresponding to lower household incomes than states that do pay income tax because employers will have to pay more salaries, higher salaries, in order to compensate for those employees paying state income tax. So let's do a couple of things. First of all, this data that we have has all these household incomes together in one column. They are considered to be stacked. So the first thing we need to do is separate this into two separate columns, and we're going to use PHStat to do that. Obviously, we're going to separate it into a column of incomes for states that do have income tax versus states that do not have income tax. So we're going to go to PHStat and we'll go over to data preparation and we're going to pick unstack data. And the first thing it wants to know is what is the variable that we're going to use to group these two subsections? What's the grouping variable cell range? And we're going to group them by whether or not there is state income tax. So our grouping variable is this variable called state income tax. So I'm going to select those. And then it asks me, okay, where is the stacked data that I want to unstack? And that's going to be my column of household incomes. So I select both of those. Again, I included the label. In my selection, I have this box checked, and I'm going to click OK. And what PHStat generates for me is a column. It's just called yes and no because those were the values that were in that state income tax column. But I'm going to go ahead and just add a little bit of text to that just so I remember. So this says no state tax. And the other column, I'm going to say yes, state tax. Okay, so now I'm a little clearer when I see these two columns on what they are. Just expand these columns a little bit. So now you'll notice I have two columns of data. Each one of these are the household incomes in those metropolitan areas in those given states. And you'll notice that I have quite a smaller number of states that have no income tax. Only about 65 of those, sorry, not states, but household areas that are in states that have state income tax. We only have 50 states. So I've got 65 metropolitan areas that are in states that have no state income tax versus the rest of my whole set was 325. So quite a few more that have that do have state income tax. All right, and what we're going to do is we're going to check to see, again, the claim is that, let's go back and take a look at the wording. We're testing the claim, is it true that average household income is lower in states that have no state income tax compared to other states, compared to the states that do have state income tax? So we need to think about, how do we want to craft this claim? So let's go ahead and craft those hypothesis statements. And first of all, our claim is going to be captured in the statement like this. We want to know that the difference of the means, remember, if we said that states with no income tax have salaries or incomes that are lower, then if I take the average of the states with no income tax and subtract the average of the states that do have income tax, I'm anticipating, the claim is, that that difference would be negative, because the states with no income tax charge lower salaries, and a lower number minus a higher number is going to give me a negative difference. So the alternate statement is that the difference of means, subtracting in this order, no state income tax minus state income tax, is going to be less than 0. And therefore, our null hypothesis statement is that that difference of means, subtracting in the same direction, no tax minus states that do have tax, the null hypothesis is that the difference in that direction would be greater than or equal to 0. Spend a bit of time thinking about this so we were really clear. The key is that the order of the subtraction is going to determine whether my claim is that the difference is less than 0 or the difference is greater than 0. So if I'm taking the number I'm anticipating or I'm claiming to be smaller, that is the income in states with no tax, and I'm subtracting from that the average for the value that I expect to be higher, the income for states that do have state income tax, then that difference should be less than 0, and that should be what's reflected in the claim. Okay. So that's sort of step 1 in our process, and step 2 is to determine a significance level. None was specified so far, or we're specifying it here. We're going to use a significance level of 5%. That's 0.05. Okay, so let's go ahead and conduct this test, but we have to remember that in a difference of means tests, now these clearly are not paired or matched samples, so this is going to be an independent sample analysis. And we have to remember that there are 2 options here. We're either going to be doing what's called a pooled variance test or a separate variance test, but we need to do a step first in order to determine which of those we're going to be doing. So as you'll recall, we're choosing between, we have to decide, first of all, does it look like the variance in these 2 samples that I now have for states with no tax versus states with tax? Does it look like those variances are very similar? In which case we'd say the variances are equal or they're pooled. We can do what's called a pooled variance test. Or is it a situation where the variances of the 2 groups are so different that we have to use an unequal or separate variance test? And what we're going to do first, if you follow this flowchart backwards, to step number 1, the first thing we're going to do is a test for the equality of variances. This is an F test, and we need to do this to determine which of the 2 options to pick for my actual difference of means test, pooled versus separate, to use the language that PhStat uses. So let's go ahead and do that first. I'm going to go back to my data now that I've separated my incomes, my household. Remember, these are metropolitan area average household incomes in states that have no state tax versus states that do have state income tax. And what I'm going to do is I'm going to calculate the variance, no tax, and that's going to be equals VAR, and I'm going to select my values for the metropolitan area household incomes for the states that have no income tax. There's a large number, remember it's a variance, so we've got squared terms hanging around in there. and that's okay. And now I'm going to calculate my variance for my household incomes for states that do have income tax, and that's going to equal state income tax, and that's equals VAR. And I'm going to select now my column of values under yes, state income tax. And as we can see, one of these values is larger than the other. I've got 129889726 and 196558030. So clearly the variance here that I have highlighted for the states that have a state income tax is higher. I'm going to keep this in mind because when I go to do my F-test, I want to put this variable in the numerator and we'll conduct the test as an upper-tailed test. So let's go ahead and do that right now, remembering that the larger, the sample that has the larger variance is the one we're going to put in the numerator, what we're going to call our population 1 in this pH stat test. So remember, first thing we're doing is our F test for the equality of variances. So let's go pH stat. We're going to go to a 2-sample test with unsummarized data. And I'm going to go down here to the bottom to F test for difference of 2 variances. I'm testing to see if the variance are equal versus is one significantly larger than the other. And I'm going to use the same significance that I determined for the overall test. That's 5%. My population 1 sample is going to be, I'm going to pick the one that has the larger variance, and we determine that to be the states that have a state income tax. So that's the first variable that I'm going to select here as what's called population 1, and the other one will be population 2. So I'm going to scroll back up to the top here. And I'm going to select my column of my incomes for my states that have no sales tax. Sorry, no state income tax. And then I'm going to conduct this as an upper-tailed test. Okay? Alrighty, I double check here. I've got my column B's here for population 1, column A's for population 2. Notice these two variables, these two samples, sorry, have very different sample sizes, and that's not a problem. We'll see that reflected maybe in degrees of freedom or something, but we don't even need to look for that. Okay. So this is a result of the F test for difference of variances, and all we have to remember is that the null hypothesis for this F test is that the variances are equaled or pooled. And what we're going to do is look at the p-value and compare that to our significance level of 5%. And here we notice that our p-value is 0.0243, and that is less than 0.05. So we will reject the null hypothesis for this F test. Now, remember, that null hypothesis for the F test was that the variances are equal. We are now going to reject that and say the variances are unequal or they are separate. So this tells me that when I go now to do my difference of means test on my unstacked samples, then I will be conducting a separate variance test. Again, if we're looking at the results of the F test for the difference of the means, if that p-value is low compared to the significance, then we're going to assume that the variances are unequal or separate. And you can go back to the flow chart just to see that that makes some sense. Okay, so now we can conduct the actual test on the difference of means. Let me go back and just recap for you then what those statements are for this test. Now we know we're going to conduct this using the separate variance t-test. And our alternate hypothesis, our claim, is that this difference of means, if we subtract states with no tax minus states with tax, we're claiming that that difference in incomes is negative, is less than 0 versus the null hypothesis. That's going to help us set up this test properly. So based on our F-test results, we're going to go to two-sample test, and we're going to pick not pooled variance, but separate variance, because we rejected the idea that the variances were roughly equal. They're different from each other. They're separate from each other. So we're going to use the separate variance t-test. Okay, well, remember that based on our hypothesis statements, our null hypothesized value is 0. We will be doing a lower tail test because our alternate hypothesis says that this difference, if we subtract it in this direction, is going to be less than 0. It's going to be negative. Hence, this negative less than sign indicates a lower tail test. And that's assuming we set it up as subtracting our incomes for no state tax minus incomes for yes state tax. So my population 1 that I'm going to select is going to be my values for no state tax. Oops, Daisy went too far there. And my values for what I'll call population 2 will be my incomes with state tax. I'm going to scroll back up to the top, click in this box here, and select yes state tax for population 2. Okay, and again, remember we've set this up as a lower tail test because of that less than sign in the alternate hypothesis statement, and now I click OK. And what does PHStat tell me? Here again, remember the null hypothesis is that the difference was greater than or equal to 0. And PHStat calculates the summary measures on these two samples. That's a number of intermediate calculations that we're not going to concern ourselves with, but we're going to focus on this p-value from the test. And we see that the p-value you get is a 0.0494. Now, this value, we're going to compare it to the significance of 0.0500, and it is less than 5%. Now, you'll notice it's very close to 5%, 0.0494, but it is less than 0.05. So we are going to reject our null hypothesis. So that says that the evidence does show strong support for the claim, and we'll return to our original claim. We're saying that we're rejecting the null hypothesis. The data supports the alternative hypothesis statement, and therefore we would say yes, the evidence does support the claim that average household income is lower in states that have no state income tax compared to states that do have state income tax. Okay, so I hope that was useful for us to see that process of stepping through the two steps of a difference of means test for independent, unpaired samples, where we have to do, first of all, an F-test to determine whether the variances of the two samples are similar or if they're very different, and that will determine whether we're going to use our pooled variance t-test or our separate variance t-test. In this case, we had to use the separate variance test. So again, take a look at this flow chart, take a look at this this video again, and just make sure you're clear on how things line up. Of course, paying attention to the fact that the order of the subtraction in our in how we structure our statements is going to impact whether we use less than or greater than in this particular case. All right. Again, this is worth checking out a few times and trying a couple different examples to make sure we are pretty clear on what's going on. Okay, hopefully this has been helpful for you, and we'll see you in class.